So we get started now. So last time in the previous video, we went as far as proving the trigonometric identity given on question 2B1. But we can pick it up from there in case you didn't watch the video, or in case you missed the online session. So 2B1, we're told to prove sin 3x equals 3 sin x minus 4 sin power 3 x. So we're told to prove this identity. So to prove the identity, we can pick one side. Let's start with the left-hand side. We must be able to produce what is on the right. So the left-hand side has sin 3x equals, we know that this can be written as a double angle or sum of two angles. The angle 3x can be split into 2x plus x. Now this expands into sin 2x cos x plus sin x cos 2x. Remember this identity? And then we can make substitution for sin 2x. We can make substitution for sin 2x. And so sin 2x is 2 sin x cos x. That is the substitution for sin 2x, then by cos x. This cos x is this one here, where sin 2x is, we've put the identity, this. And then we can do the same also here, make some substitution. So we have plus sin x, where cos 2x is, we write cos squared x minus sin squared x. That's the identity. And then we can expand here. So if we do some expansion here, we're just going to multiply these two, since all these terms are multiplying, right? So it will be this by that. And so this will be squared because this is the same quantity being multiplied twice. So we have 2 sin x cos squared x plus sin x. Then inside the brackets here, we can express cos in terms of sine, and so we get 1 minus 2 sin squared x. So this is what we get. Proceeding, we can substitute this. We can express cos squared x in terms of sine, and so we get 2 sin x, where cos squared x is, we write 1 minus sin squared x, then plus sin x 1 minus 2 sin squared x. Okay, now we can do the expansion. When we expand here, we get sin 2 sin x minus 2 sin power 3x. Can you kindly unmute yourself? Try to mute yourself. Okay, we expand there also, we get sin x minus 2 sin power 3x. Then we can group the like terms here. We see that this and this are like terms. This and that are also like terms. So we get 2 sin x plus C sine X. Then minus, we now come to this and that. So we have minus 2 sine power 3x minus again 2 sine power 3x. Simplifying, this gives us to observe that these are like terms and they're adding. This is 2 of each, that is a single quantity. So we get 3 there. We get 3 sine x. Here also, we observe that this and this are like terms. So when we simplify, we get minus 4 sine 3x. Okay, so we have proved. We have proved here. This was the required proof. We go to the next screen and the next question. I want us to solve this equation 3 sine x minus 4 sine power 3x equals half, and the domain for x is given for 0 less or equal to x less or equal to 2 pi. That's the domain. So we observe that this is just the identity for sine 3x, the one we just proved. So we have sine 3x being equal to half. And then next, we introduce sine inverse on both sides, sine inverse, then sine of 3x. So here we have sine inverse of 1/2. So sine inverse by sine, you know that the two get rid of each other, and so we just remain with the 3x being equal to sine inverse of half. Now, what is sine inverse of half? Sine inverse of half gives us 30 degrees and 150 degrees. Because this value is positive, this value is positive. So for sine 3x to be equal to positive half, it means we're looking at the quadrants where sine is positive, of which sine is positive in the second and the first quadrant. No wonder we have the two angles, 30 degrees from the first quadrant and 150 degrees from the second quadrant. Now, since we're solving for x, we're going to divide by 3 on both sides, and so we get x is equal to 30 degrees over 3, 150 degrees divided by 3, so that x is equal to 10 degrees, 50 degrees. So this was the required solution. Yes, Chole.
So I'm behind on the part where we are finding the sine inverse. Is it the same as finding sine?
Okay, this part?
Yes, sir.
Okay, wonderful. So what it is that we want to make this, we're solving for x in this equation. So now to solve for x, when we have a trigonometric function here, we don't do like for instance, if you had maybe 4x is equal to maybe some number 10, here you divide by 4, that's when you're solving for x sign, and you get your value. But when it is a trigonometric function, we don't like divide by sign, we divide by sign, so that you get rid of this and remain with this. No, this instead is expressed.
Wait, why did you press so that next time I don't have to?
Pardon?
Oh.
You can mute yourself, please, if you're discussing with your colleague. Okay, I'm trying to answer Cholo's question. So Cholo, we are saying that when you've got a trigonometric function, like 3x is equal to maybe some number half, under trigonometry, we don't divide by sign, even this side by sign, we don't do that. Because sign cannot just exist on its own. It always has to be the sign of some angle. So to get rid of this sign, instead of you saying it's divided by sign, we divide by sign on both sides. Instead of doing this, which is a wrong method, the correct way is to introduce sign inverse. It's like you have 3x, let's say you've got 4x is equal to maybe 2. You are solving for x. For you to get rid of the coefficient of x here is what? 4, right? So since you are solving for x and the coefficient of x here is 4, you need to get rid of this coefficient and ensure that you only have a coefficient which is 1, right? By the end of your calculation. So to get rid of this 4, what do? You need to introduce the multiplicative inverse. So the multiplicative inverse of 4 is 1/4. So you say introduce 1/4 on both sides. Even here, you're going to have 1/4 by 2. So you have introduced the multiplicative inverse in order for you to remain with x alone. So you have x is equal to the value that you're going to get there. So this value you introduced to get rid of the given coefficient, this value introduced is what we call the multiplicative inverse. So now when it is a trigonometric function, just in layman, the multiplicative inverse of this function is sine inverse. So to get rid of sine here, so that you just remain with 3x, you introduce the sine inverse on both sides. So to get rid of this sine, so that you remain with 3x, you need to introduce sine inverse on both sides. So that sine inverse and the sine, the two will get rid of each other to give us a 1. 1 times 3x, we get 3x. That's how the sign disappeared on the left-hand side. Hope I've answered Cholo's question. Cholo, is it clear?
Clear.
Okay. So we can move on to yes, Sikelan. Yes, Sikelan.
I have a question on the what is the 4 sine cubed x.
This part?
Yes, it wasn't part of the main solution. So I wanted to ask, we just ignore it?
What do you mean it wasn't part of the main solution? Here, what we do, what
Sir.
we have done is that what we have on the left-hand side, this part I'm circling, are you seeing it?
Yes, sir.
So this part from the previous proof, we have already seen that this means this.
Oh,
This,
okay, sir.
you see the logic, eh?
Oh, yes, sir.
Okay, so we can move on.
Yes, sir. I get it now.
Well, so we go to the next part. So the next question is C1. They want us to show that 2x minus 1 is a factor. Is a factor of 4x power 3 minus 7x plus 3. Okay, so for us to show that this is a factor, we need to equate this to 0 and solve for x from this factor, meaning that we have 2x minus 1 is equal to 0, which gives us x is equal to half. So this half will now be substituted in the polynomial. Where x is, we're going to put half, the power 3 minus 7. Where x is, again, we put half plus 3. When we're able to hit a 0, then truly this will be a factor. Well, 4 times 1 over 8 minus 7 over 2 plus 3. So simplifying this part, this and this reduces to 1 over 2 minus 7 over 2 plus 3 over 1, which simplifies into, we get that as the common denominator. We get to as the common denominator or the lowest common multiple of the denominators. This into that. So we have 2 into this, it's 1 by that one, we get 1. 2 into this, it's 1 by 7, we get minus 7. 1 into this, 2 by that, we get 6. So we have 1 minus 7 plus 6. So we can add this and this to get 7, isn't it? So we have 7 minus 7 over 2, which gives 0 over 2, giving us 0. So if we're able to hit a 0, it means this is a factor. 2x minus 1 is a factor. Okay, yes, Emmanuel Kasonde. Should we move on?
Yes, sir. So I want to make point. What if I use the long? What if we use the long division?
Okay.
Then after it use a quotient of 0, then you say since after dividing this factor and it use a 0, a quotient of 0. No, not a quotient, a remainder of 0, sorry.
Yeah,
The remainder of this function, we use a long division. Is it correct? Can I get a mark?
In fact, it's very much correct. So that's the other method one can opt for. Yeah, if they're able to get the remainder 0 and then some quotient, then it means they've shown. Yeah, that's
all right. Thank you very much, sir.
Yeah.
All right. Thank you.
Okay, so you can go to the next page, next screen. So move on to 2C part 2. Hence, we solve now the polynomial plus 3. So, to solve this polynomial, since this is a factor, since x equals half, is a factor, as we have seen from the previous one, right? So we can reduce this polynomial in synthetic division, where we get the coefficients of the polynomial. The coefficients, these are the ones that we get. If you want to laugh, you can mute your voice so that others do not get your noise. So we have 4, then we have a 0 here, then we have -7, then we have 3, we have plus, multiplication, then we can drop the 4, so multiply the half, this half multiplied by this, we get 2, right? When we add the 2, adding this and this, we get 2. Again, multiply half by these 2 that we have gotten, we get 1. When we add the 2, -1, -7 plus 1, we get -6. -6 multiplied by half, we get -3. Adding the 2 gives us a remainder 0, meaning you are getting now the quotient. The quotient 4x squared plus 2x minus 6 as the quotient, and the remainder is 0. Okay, so this implies that you have now reduced the polynomial. You have factorized the polynomial into 2 factors, 2x minus 1 and the 4x squared plus 2x minus 6. So now the next step is now to factorize this one, the quadratic function. We can still factorize this one. If you want, you can use synthetic division or use some other method that you already know. So if you are to use synthetic division, we observe that 1 is a factor. 1 is a factor. When you put 1 here, you have 4. We put 1 there, you have 2. 2 plus 4, you get 6 minus 6, you're getting 0. So 1 is a factor. So we are saying that 1 is a factor of the polynomial, which is a quadratic equation. Those factors are 4, +2, and -6. Then you have a plus here, you have a times here, then you drop this, 4 you write there. Next, you have 1 times 4, you're getting a 4. Adding the 2, you're getting a 6. Then 1 times 6, you get -6. Adding the 2, you get 0, which is the remainder. So at this stage, your quotient is 4x plus 6.
Sir.
Yes, please.
Sir, when you add the 2 -6, doesn't it give you a negative? It gives you a -12.
I think it's just a mistake. It's just a mistake, sir. You were supposed to write the +6 there.
Okay, thank you for noticing such a mistake. This is supposed to be 6, eh? Thank you very much. Which is coming from 1 by 6, so giving us that 6. So 1 times 6, giving us this 6. Okay, thank you for taking note of that. Can we move on? Okay, so
yes.
We have factorized the quadratic polynomial factorizes into x minus 1 and 4x plus 6. Now the whole polynomial factorizes into the product of the 3 factors now. which are 2x minus 1, then x minus 1, and 4x plus 6. So this factorizes the whole polynomial equals 0 since we are solving the polynomial. Equals 0. So if the product of the three factors, this and that, is 0, it means either this factor is 0, or this one is 0, or this, the last one is 0, or all the three are zeros for the product to be 0. And so we say either 2x minus 1 equals 0, or x minus 1 equals 0, or 4x plus 6 equals 0. In which case we get x being equal to a half, then x is equal to 1, and x equals negative 3/2. So these are the values of x required. Okay, should we move on? So we move on to question 3a. 3a, they want us to find the values of x for which the absolute value of 2x minus 1 is greater than the absolute value of x minus 1. Okay. So by definition of absolute value, this means 2x minus 1, we square it, and then square root. That's the definition of an absolute value function or not just function. Even after the inequality of x minus 1, we square it, then introduce a square root. Then next thing, we're going to square on both sides. So we have x minus 1 squared, then we square this side, greater than, we have x minus 1, the square root again, we also square the other side. So doing this gets rid of the square root, because we know that the square and the square root, the two are multiplicative, the two get rid of each other. So we obtain 2x minus 1 squared greater than x minus 1 squared, which when we expand, we have 4x squared minus 4x plus 1 greater than x squared minus 2x plus 1. Collecting like terms, we have 3x squared, then minus 2x greater than 0. This is what we get. We can factor out x here, and so we have 3x minus 2 greater than 0. So this is an inequality. So to solve an inequality, you know that you need to get the critical values. Here, critical values are critical values. We have x equals 0 and x equals 2/3. So we now have a number line. We have your number line here, which is being divided into 3 regions. You can have a 0 there, you can have a 2/3 here. So you have like this. Okay, so we're now coming up with a table. So this is your number line, which is being divided into this region, and this region, 3 regions, because we have 2 critical values. So in this interval, we can pick some value of x and test into the inequality. In the other interval and the last interval, we also do the same. So here we can pick some x if x maybe is equal to -1. Here we can pick if x equals 0.5. Here we can pick if x equals maybe 1. Then of the factors, we have x. Then we have 3x minus 2. And finally, we have the product of the two factors. So let us get the signs of each of the factors and then finally the product. So when we substitute x equals -1 here, the result is negative. When we substitute 0.5 for x, the result is positive. When we substitute 1, also the result is positive. So in both cases, we have positive and positive. We can go to the second factor. When we substitute a -1 here, the result will be negative here. Then substitute 0.5, the result will be negative. Substitute a 1, the result will be positive. And so we get negative, negative, positive. The product of the signs here of the factors, yes, Vivusa.
Can you just repeat the explanation starting from how the roots got cancelled? My network tripped a bit, so I didn't hear any of the explanation from.
On this part?
Yeah.
Okay. How about at this stage, did you get it? From this stage to this stage?
That's where my network started tripping from, so I didn't get anything.
Okay, okay. So let us first assist Vivusa before we proceed. Okay, let me just make a demarcation here. So we said that the modulus of 2x minus 1 greater than the modulus of x minus 1. So by definition of the modulus, we said that this means that we have 2x minus 1 to the power 2, then square root. Then greater than, here also have square root of x minus 1, then square. So this is the meaning of the absolute
Can't hear
value.
anything.
You can't hear anything?
Yes, your voice is cutting. I don't know if it's my network,
Yeah,
but your voice is cutting.
I think it should be network. Let me repeat it just once more. So we said that we apply the definition of the absolute value here. So by definition of the absolute value or the modulus function, this means this. Meaning you get what is inside, you write it and square it. This is the power 2 you are seeing. Are you able to see the power 2? Then you introduce a square root.
Yes, I can see it. Yes.
Then, okay. Equal after the inequality, inside the modulus you have x minus 1, right? So you get it,
Yes.
x minus 1 and square, then introduce a square root. So from this stage to this stage, you have not done anything yet. You have just applied the definition of the absolute value. Are you okay at this stage?
Yes, I'm okay up to this stage.
Okay, okay. That one, we can get some pepe mwana oko. Try to mute it so that others do not hear the pepe mwana. Okay, so we can now proceed. So now, Bibusa, when you are done with this stage, the next step now is to get rid of this square root here. You get rid of this square root. How can you get rid of this square root? We square on both sides. So squaring on both sides. So we have square root of 2x minus 1. Then you introduce a square. I mean, not square root. You introduce a square. So this square that we have introduced will take care of the square root. So the square and the square root, the two get rid of each other. We'll just remain with what is inside. Are you okay? So the reason why we are squaring on both sides is we want to get rid of the square root. Similarly, on the other side of the inequality, you have square root of x minus 1 squared. So now, how do you get rid of the square root? How do you get rid of this? To get rid of the square root, you can introduce a square. You can introduce a square like this. So this square and the square root, the two will get rid of each other. The square and the square root, the two will get rid of each other. So this square and the square root goes, we remain with 2x minus 1, then square greater than, then equally the other side, we have square and square root will go, and so we remain with x minus 1 squared. So that's how we arrived at this stage. Okay.